Welcome to the deep dive. Today we're doing something a little different. We're taking what might be the single most mundane item in a high-tech conference room.
The little power box in the table?
Exactly, the table box. And we're going to put it under the microscope. Our source material is the incredibly dense spec sheet for the Kramer TVUS1 KWC-BC.
Right, and our mission here is to really unpack the hidden complexity. I mean, the regulatory hurdles, the engineering that goes into something you just drop your phone on.
Without a second thought.
Yeah. So this specific product, the TBUS1 KWC-BC, it's a modular enclosure, sits flush in the table, and it has this integrated wireless charging spot.
And it uses the same inner frames as some of its cousins, the TBUS1 Axle and PBUS1N. But that's where the simplicity ends, because adding wireless charging, well, it demands absolute precision.
Oh, it does. You have to perfectly machine your corporate tabletop. The cutout dimensions are, get this, 152 by 191 millimeters.
Okay.
With a tolerance of plus or minus just 2 millimeters.
Wait, 2 millimeters? That's what, the thickness of a thick credit card? Why so tight? Why does that, that tiny 0.08-inch gap matter so much?
Because it's not just for looks. That precision is actually mandated by safety standards.
Huh?
It ensures the enclosure seals correctly, to prevent spills or even dust from getting in and shorting out the electronics. It's a safety feature hidden in a dimension.
Got it. Okay, let's pivot to the power itself, because here's what I found fascinating. This device doesn't just pick one standard.
It completely refuses to pick a lane, and that's a very strategic choice. It's compliant with both the CHU standard,
Which most people know.
right, and also PMA Type 3. By supporting both of these, often competing protocols, the manufacturer just guarantees that it'll work with pretty much any device.
Even if it makes the engineering way more complicated.
Exactly.
And that complexity, it really shows up in the power numbers. We've got a clear input, 12-volt DC at 2 amps. Simple enough. But the output, it gets layered.
It does. The feature list gives this broad range, 6 to 15 watts.
Right. But then the hard spec sheet says the charging power output is 900 milliamps max. So what's going on there? Why the two different figures?
Well, the 6 to 15 watts, that's likely the rated capability of the coil system itself. But the 900 milliamps, that's the regulated verified current the device will actually deliver to your phone to keep it safe.
So it's advertising potential, but delivering safety.
Precisely. And if you look at what the charging spot itself consumes, 12 volts at 1.25 amps, you can see the real metric here.
Which is?
Efficiency. The source material locks the charging efficiency at a really demanding 73%.
Wow.
For wireless transfer, where you lose so much power to heat and noise, hitting 73% is a huge engineering hurdle. It means almost 3/4 of the power it draws actually makes it into your phone's battery.
And speaking of managing all that, there's this other connectivity detail. It mentions a 1 amp current input using 802.15.4 based RF channels. What is that?
That's the device's brain, basically. IO2 802.15.4 is the standard for low-power mesh networking, think Zigbee. It tells us the TBUS has its own little private communication channel.
So it's not on the corporate Wi-Fi?
Nope. It's likely used to manage heat and make sure those dual CHI and PMA protocols are negotiating the power transfer safely.
And managing all that while hitting 73% efficiency, that's what sends us straight into the regulatory maze, doesn't it?
Absolutely. The list is staggering. You've got environmental mandates like RoHS and REACH, sure, but the critical ones are the safety checks, EN 60950- and UL 60950-1. Those are what prevent fires in an office building.
And the operating constraints are so specific. 0 to 40 degrees Celsius and 10 to 90% non-condensing humidity. It's built for an air-conditioned room.
It is. Even the fuse rating, T6.3A250V, is there to assure the client this thing won't be a point of failure, even if the building's HVAC goes down for a bit.
So when you boil it all down, what does it all mean?
It means that behind the simple act of dropping your phone on a charger, there is this incredibly complex object.
An object that has to hit 73% efficiency, support 2 competing standards, fit into a 2mm tolerance, and satisfy a massive stack of global safety documents.
It's proof that simple convenience is built on incredibly complex, constrained design.
For our final thought, as you drop your phone on the next wireless charger you see, consider this. The spec sheet lists compliance for EMC emission EN 55002. So think about it. What specific electromagnetic interference rules does a tiny in-table device need to follow just to make sure its power transfer doesn't add static to the CEO's conference call?